How can a particle be in two places at once? Ever stop to think that maybe, just maybe, reality isn't quite what it seems? What if the very fabric of existence is far stranger than we can imagine? Get ready to question everything you thought you knew about the universe. In the world we experience every day, objects are in one place at a time. A ball is either on the table or on the floor, never both. This is the bedrock of classical physics. But zoom down to the quantum realm, and the rules change dramatically. Quantum mechanics tells us that particles can exist in a combination of all possible states simultaneously. This is superposition. Imagine an electron. It can have a property called spin, which can be either up or down. In superposition, the electron is spinning both up and down at the same time. This mind-bending state exists until we try to measure it. Only then does the particle choose one state or the other. It's like the universe can't make up its mind until we look. To really grasp superposition, let's dive into the famous double-slit experiment. Imagine firing single electrons at a barrier with two slits in it. What do you expect to see on the other side? If electrons behaved like tiny bullets, we'd expect two distinct lines of impact behind each slit. This is what classical physics predicts. Simple, right? But here's where things get weird. Instead of two lines, we see an interference pattern, a series of alternating bands. This is exactly what happens with waves, like light or water. This means the electrons are somehow passing through both slits at the same time. They're interfering with themselves, creating the wave-like pattern. It's as if each electron is in two places at once. Even more bizarre, if we try to observe which slit the electron goes through, the interference pattern disappears. The act of observation forces the electron to choose a single path. It's like the electron knows we're watching. To illustrate the strangeness of superposition on a larger scale, we have Schrödinger's cat. Imagine a cat in a sealed box with a device that has a 50% chance of releasing a deadly poison. Until we open the box, quantum mechanics says the cat is both alive and dead simultaneously. It's in a superposition of life and death. This thought experiment highlights the seeming absurdity of applying quantum principles to macroscopic objects. It's hard to imagine a cat being both alive and dead at the same time. However, it's important to remember that superposition is a fundamental property of the quantum world. It's perfectly normal at the atomic and subatomic level. So, how does a particle in superposition choose a single state when we measure it? This is where the concept of the wave function comes in. The wave function is a mathematical description of all the possible states a particle can be in. It's like a probability cloud, showing the likelihood of finding the particle in any given state. When we make a measurement, the wave function collapses. The particle is forced into one definite state, and all other possibilities vanish. This means that our observation literally changes the reality of the particle. Before we looked, it was in multiple states. After we looked, it's in only one. Superposition isn't just a theoretical curiosity. It's the foundation for some incredibly powerful technologies we use every day. Think about MRI machines. They use the principles of superposition to create detailed images of the inside of your body. The magnetic fields manipulate the spins of atomic nuclei, which exist in superposition. Lasers also rely on superposition. The precise control of light emission is only possible because of the quantum properties of atoms, including their ability to exist in multiple energy states simultaneously. Perhaps the most exciting application of superposition is in quantum computing. Quantum computers use qubits, which, unlike regular bits, can be both 0 and 1 at the same time. This allows quantum computers to perform complex calculations that are impossible for even the most powerful classical computers. They can solve problems in drug discovery, materials science, and artificial intelligence. Superposition challenges our fundamental understanding of reality. It suggests that the universe at the quantum level is probabilistic, not fixed. The universe doesn't decide what state a particle is in until we observe it. Before that, it exists in a blurry superposition of all possibilities. This raises profound philosophical questions. Are larger systems also in superpositions, even though we don't perceive them that way? The answer might lie in a phenomenon called decoherence. Decoherence is the process by which quantum superpositions are destroyed by interactions with the environment. This is why we don't see everyday objects existing in multiple states. Some physicists even speculate that superposition could lead to the existence of parallel realities. Every time a quantum measurement is made, the universe could split into multiple branches, each representing a different outcome. The quantum world operates under a completely different set of rules than the world we experience every day. At the tiniest scales, particles can indeed be in two places at once. This challenges our intuition and forces us to rethink what we mean by reality. It suggests that the universe might only exist in a definite state when it is observed. If your mind isn't completely blown right now, it's okay. This is just the tip of the iceberg when it comes to the mind-bending world of quantum mechanics. Now it's your turn. Dive deeper into the quantum realm. Read books, watch documentaries, and explore the fascinating world of physics. Share this video with your friends and spark a conversation about the nature of reality. Most importantly, stay curious. Science is full of surprises, and the more we explore, the more we realize how much we still have to learn. The universe is waiting to be discovered.